Luminous luminaries of LEDs, it's Prof G, and while everyone is welcome to follow along this lesson, and there will be big learning for all, there are specifics in this lesson for students in my class. Now, all of my students have received a PixelBlaze version 3, a bunch of LED matrices, a 5-volt 10-amp power supply, and a barrel jack with terminal blocks. Now, I'm going to show you how to set things up for initial work and point out some things that you should be aware of. I'm also going to point out a few specifics to the uniqueness of the Boston College network. I'll show you how you can switch between a campus and home network. But with that said, let there be light. So here are all your parts, and if you've got any of these extra loose JST-SM wires, save them and bring them back to class. We're going to use them in future projects. Now the first thing I'm going to do is access my PixelBlaze and make sure that my brightness is set low. And I'll also use this to configure the number of lights that I'm using, the LED settings, make sure the LED standard is set properly, set the color order, and we'll set up our pixel mapper for our 16x16 matrix. Now, lowering the brightness is really important. We're going to do this so that we don't tax our board by demanding too much power to the LEDs. So with no lights attached to my board, it's okay to power from the USB cord and even plug this into your computer at this point. But do note, we're not going to be powering our board from USB when we add lights. So a rule of thumb for our work in my class is going to be only plug in your PixelBlaze to your USB port if you don't have any LED lights attached. Now also, and this is a warning from the electromage folks, you should never use your PixelBlaze plugged into your USB port with a separate power supply plugged in to connect the LEDs. This is something that you'll see on projects that you do with boards like the Raspberry Pi Pico, but it's not what we do with the PixelBlaze. The PixelBlaze handles power very differently. It has what we call back channel power. The PixelBlaze supports power flowing back through the LED strip to the PixelBlaze. We won't be using USB and separate LED power together. More specifics beyond that rule of thumb in our power lesson. Now for my students, to connect to your board, you need to select the Boston College Wi-Fi network, not EduRoam. You won't find your board on EduRoam. It only runs on Boston College Wi-Fi. And as I mentioned in class, right now you've got to create a guest account to use the Boston College network at helix.bc.edu. You can't use your BC credentials. So go to that web page, click on the guest registration page, follow the steps to get an account and sign in. It's going to time out every 24 hours, so you'll have to redo this, unfortunately. And if you're logged into the Boston College network and your PixelBlaze is plugged in with no LEDs attached, open a browser and head to discover.electromage.com. And you'll see a list of all the PixelBlaze boards on the network. Find and select your board from the list. Now, it might take up to a minute to connect to your board, but you should eventually see the web interface. Now, one student in class had a hard time connecting. She was using Chrome, and it had some kind of odd settings that we couldn't find. I used Chrome without any problem, but when we switched her to Safari, she was able to access things no problem. So if you're running any problems, you're using Chrome, try another browser. And again, to underscore this with my students, if you try accessing discover.electromage.com from EduRoam, which is probably your default Wi-Fi network, you're not going to see any boards. No PixelBlaze boards are allowed on that network. You need to be using the Boston College network, and you need to be logged in as a guest. So if you connected to your board, head to Settings. Now the first thing we're going to do is set our brightness to just 20% so we don't demand so much power when lighting up our LEDs. An earlier lesson mentioned that the human eye actually sees brightness increasing logarithmically, not linearly. You can't see much difference when you hit 70% or even 50% brightness, and these lights are very bright. 20% should be fine for most work. And if you set your brightness to 20%, this should be enough for 3 16x16 matrices chained together. You only have 2, so that's well within tolerance. But if you're curious about the calculation, here it is. 16x16 equals 256 lights. And each neopixel LED can draw up to 60 milliamps of power if they're on full white at full brightness. So, on a 16x16 light matrix at 20% brightness, if all lights are on maximum white, the LEDs on this panel will only draw 3.72 amps, about 3 amps. Now we've got a 10 amp power supply, so we can actually multiply this by 3 if we attached 3 of these matrices together. That'd be 768 lights, and at 20%, that would only draw 9.216 amps of power. Now the project isn't just LEDs, we also have to account for the power consumed by the PixelBlaze board, but even if we have a sensor board attached to our PixelBlaze and we're running Wi-Fi, that should add around 120 milliamps at most. That'd still mean our project consumes around 9.336 amps for all 3 panels if all of them are bright white, well within the tolerance of the 2 panels that each student has. And another thing to be aware of, if you're not turning on all of your lights in the brightest white, then you're not hitting that full 60 milliamp power draw. The rule of thumb is with most animations, you're usually drawing between 20% and 2/3 of the maximum power draw per light. Think of it this way. If white is 255, 255, 255, and yellow is 255, 255, 0, then that maximum yellow is only drawing 2/3 of what a maximum white would draw. Any black pixels in your animation, you're drawing nothing. And many of the colors in your animation are a mix of RGB that aren't at 255 max. We'll cover more on power in a future lesson, but just know that if you set your lights to 20%, you should be in good shape. Now, just so that you know, if you were running your project and you didn't have enough power, your PixelBlaze board would probably stop working, your lights might freeze, or they might dim or flicker, or even turn off. If you see any of those symptoms, the first thing you should do is check to make sure that your brightness is low and that you haven't added too many lights. Now there is one more caveat. These JST connectors with the plastic and the wires attached to them are usually rated at only about 3 amps. Now if you're worried about safety, always check with an electrician or somebody who has strong electrical training. That's not me. My PhD is in information systems, not electrical engineering. But for projects that we do in class, we don't run our lights for more than 2 or 3 hours at a time. We vary our animation so we're not at full brightness, so we're not demanding that full power. We shouldn't have to worry about overloading our wires. If we did overload things, we'd see the plastic would get soft, the end of the wires might turn black, and you certainly don't want to start a fire by getting things too hot when you're overloaded and running unattended. Now that's our caveat for now. I'm going to show you how to add additional wiring to take the load off of these JST connectors in a future lesson. So let's finish our setup for a single 16 by 16 light matrix. Under LED type, select the right standard for your lights. There are a bunch of selections in here, but neopixels is the standard that we're using. And you want to enter the number of lights that you're using in the pixel setting. For us, that's 16 times 16, which is 256 lights. And make sure your RGB color pattern is set properly. Now, for most neopixels, it's actually not RGB. It's in the order of GRB. That's not going to change any of the code that we write, but we want to make sure that we have this setting in here. And if you find your colors look like they're switched, you can come back here and change this value. Next, we need to set up a pattern for the layout of our lights, and we do that in the Mapper tab. So there's a pull-down menu in here, and this is where your PixelBlaze will understand how your lights are laid out. There are a bunch of light layout options built in. You can see these by pulling down this menu, and ring stands for a straight line of lights. That looks especially great if you wrap your lights around in a circle. Matrix is a two-dimensional row-column grid, and that's what I'm using. Now, if you connect multiple matrix panels together, you want to choose a multiple panel matrix. And the other two settings are for cubes. Flat side is sort of like LEDs on a box, and volumetric has the LED lights inside, so you can see all the lights inside the cube. Now there are also a ton of ways that you can map irregular or less common patterns. We won't be covering that in our first tutorial, but remember, electromage has a set of forums where you can ask experts for all sorts of advice. So with matrix selected, I'm going to click on the load example button and some code appears. Now the default that loads assumes that there are 8 pixels or LEDs in the width. You see that field here? But you can modify that width up here and the PixelBlaze will automatically look at how many LEDs you entered in the pixels field of the settings tab and it'll take care of the rest. Well, since my LED matrix is 16 lights wide, I'm going to enter a 16 in here. I also see a pattern over on the right. I'm going to click on save. And with that, we just configured our PixelBlaze to work with a 16 by 16 LED matrix, so I'm going to quit my browser. So now you can unplug your PixelBlaze from USB and put away your USB cable. We're not going to be using that for the rest of the lesson. And let's plug our PixelBlaze into the LEDs. Now, in my class, everyone has a PixelBlaze with a terminal block soldered on, and I've also screwed in a JST connector. If your wires on this connector ever come loose, you can unplug everything, then reattach the wires, screw them in nice and tight before plugging back in. So this JST connector screwed into the PixelBlaze should plug into the JST connector that's labeled DIN on your NeoPixels. Now DIN stands for digital input. That's where the signal comes into the lights. And the digital in connection isn't always consistent. I've seen NeoPixel strands, for example, that have the opposite connector to this. And if that's the case, you're going to need to swap out this JST connector that's screwed into the PixelBlaze for one that matches the connection that you need for your digital in. Now we're going to power our entire project from the auxiliary red and black power and ground wire that you see in the middle of our matrix. The technique that we're going to use will not work with standard microcontrollers like the Raspberry Pi Pico, but as mentioned, the PixelBlaze has special power management electronics that let the board get its power from the LED connection, so this is going to work fine. If you're using a different board that's not a PixelBlaze, then you're going to need to use a different wiring technique. But here, we'll loosen the screws on the plus and minus connections of the terminal blocks on the barrel jack and make sure that our power and ground are stripped just enough to push them into the terminal blocks and for the screw to bite into the metal. You don't want to strip away too much. The wires shouldn't be exposed where you risk touching other wires. If that happens, your project is going to short and stop working. Red power goes into plus, black ground goes into minus, and if for some reason you've got extra metal exposed, you can either cut and strip the wires again or add some electrical tape around the exposed bits. Now with your PixelBlaze plugged in and your terminal blocks wired to the auxiliary power and ground on your 1616 matrix, you can plug the barrel jack into the opposite end of the power supply and make sure your power plug is in the power supply and plugged into an electrical outlet, and you should see your panel light up. Look at that magnificence, and if you're not seeing magnificence, well, you might not have a playlist set up yet, but let me show you how to do that. So open a browser back up, and Boston College students, remember, you've got to have Boston College selected as your Wi-Fi network, not EduRoam, and if it's been a day since you last logged into the network, you probably need to recreate a visitor account at helix.bc.edu and make sure you use that to log into the Boston College network. But when you're on the right network, you can head to discover.electromage.com, find your board, open it up, and on this first screen here, you'll see the Patterns tab. And you can double-click on a pattern to see what it looks like. You'll see a pattern across the top of the screen that should be a linear version to match what you see in real time on your LED matrix, even though we have a 2D LED matrix. Now this pattern here, example color hue, is a good one to try first just to double check that your RGB settings are accurate. If the solid colors you're seeing on screen don't match what you're seeing on your LED lights, then you probably need to change your RGB settings, but there are a lot of great patterns in here. Many have 2D next to the name, and they look especially good on the 2D LED matrix. I love this one with spotlight in the name. It looks like a spotlight is moving around on screen. And this one with the spiral twirl is also really cool, so try out a bunch of these. And after you experiment with a few of these, you might decide, hey, I want to create a playlist that repeats a bunch of patterns that I really like. And you can do that. You can just click on playlist up here, and that lets you build a playlist of patterns to play continuously. Now you can still double click on patterns to check them out, but if you find a pattern that you like, well, you can just click on the add button that's in that pattern row. That adds it to the playlist. But I'm going to keep clicking on patterns that I like. I'm going to look specifically for ones that have 2D in their name because those look especially good when they're on an LED matrix. Continue to click on add for the ones that you like, and there are so many good ones, so explore away. Some of these are listed as sound reactive. Those work with a sensor board. And you also have the ability to edit, clone, or export a given pattern, which is a wonderful way for you to learn more about the code behind these PixelBlaze patterns. You can experiment with things on your own. The PixelBlaze language is a subset of JavaScript. There's a real-time online editor that you can access through the browser that flags any errors that you might make, but it also immediately shows the results of your working code, and we're going to talk more about writing patterns in a future lesson. But you can also search online and download other patterns. If you find one you like, you can just head to the Edit tab and open an existing file, save the pattern, and now you've got even more goodness. And now at this point, let me show you what happens if we quit the browser and I unplug my PixelBlaze, and let's imagine I come back later, I plug my PixelBlaze in, and my playlist restarts. I don't even have to get into my browser. My PixelBlaze automatically starts running through any of the presets that I gave it, so hopefully that's got you up and experimenting. So hopefully you got things working, but if you ran into problems, remember the good folks at electromage have a set of forums online where you can post questions and you'll get some friendly answers. Now, one thing I want to point out before we go, some of our students, especially those ones that live off campus, might want to switch their PixelBlaze from the Boston College network to a personal Wi-Fi network. Well, here's how you do that. Plug in and power up your PixelBlaze. I've got my LED lights attached, so I'm not plugged into a USB connection on the PixelBlaze. I'm going to power it from the LED lights, and then I'm going to hold down this button for 5 seconds until I see the amber flash. That's going to cause my PixelBlaze to act like a Wi-Fi hotspot, so I can now connect to it using my computer. Now your PixelBlaze should be in something called AP mode, and AP stands for access point, and again that means your PixelBlaze is acting as an access point, essentially a Wi-Fi hotspot. So I'm going to go up to my Wi-Fi menu and find PixelBlaze, and sometimes it takes about 30 seconds or more for this to show up, but if I peek under other networks, I can see a network named PixelBlaze and some other stuff. So I'm going to select that, and then you might have to wait for another 30 seconds, but you should eventually see a window pop up where you can configure the PixelBlaze to find and connect to your local Wi-Fi network. Now leave this in client mode. That's what you want to change to. This will let your PixelBlaze board connect to your Wi-Fi network. It'll no longer be a hotspot. And I see all of my local Wi-Fi networks listed here, so I'm going to select my local network. When you double-click on it, you should see it show up in SSID. Make sure that your Wi-Fi network name is in there. Then enter your Wi-Fi password, click Enable Discovery Service. This is going to let your PixelBlaze be found within your browser, and click Submit. And you should see a connecting message, and after another several seconds wait, then a note that says that you've connected and you can disconnect from your network, meaning currently the PixelBlaze, and reconnect to your local network. Now my Mac does this automatically, but now that I'm on my local Wi-Fi, I'm going to open up Safari and I'm going to enter this URL, discover.pixelblaze.com. Now this should show all the PixelBlaze boards that are on your local network. Find and click your PixelBlaze and you'll get into the same web interface we used before where you can work with patterns and the code editor and anything else. Now, key thing to remember is when you return to campus, you need to perform the same procedure again, but for the Boston College network. So you'll hold down this button on the PixelBlaze for 5 seconds until the amber light flashes, then find and select PixelBlaze under Wi-Fi so that it's your local hotspot, and when the configuration window pops up, find and select Boston College, not EduRoam, as your network. Make sure that's in SSID. Remove any password in the password field. Everyone in my class has a device with a MAC address that's been pre-approved to work on the Boston College network. So when you click on Submit, your PixelBlaze should disconnect from your Mac and reconnect to the Boston College network. So at this point, you can switch your Mac into the Boston College network, again, not EduRoam. Make sure you're logged in with a valid guest account. Remember, those time out every 24 hours. And then you can go to the discover.electromage.com address, just like you've done before, select your board, and start working. And if for some reason your board doesn't show up, just unplug it, plug it back in again, and after 30 seconds to a minute, it should show up. And that's it. Hopefully your work is lit. We've got more PixelBlaze lessons coming, but until then, get glowing and get out there and make something awesome.